Let's take a look at 6.1, looking at antiderivatives. So the goal in this section is to find, well, the opposite of the derivative. In other words, let's just start with a few examples. My goal is, let's pick a color here. Find the indefinite integral, the antiderivative. Well, so I'd like to know when I'm looking at this, here's the way I think about this. I'm thinking what function has derivative x. In other words, I'm looking for the function whose derivative is x. So this dx here, this means with respect to x. This is just telling us which variable we're interested in. So the question here is, I would read this, find the integral of x with respect to x, or the integral of x dx. So, well, I kind of just have to start by saying, okay, well, I know that, I don't know, should I do this down here where there's a little more room? I know that the derivative of x squared would give me an x because, let's see, I would bring down the 2 and subtract 1 from the exponent. But, I mean, if my function were just x squared, if I differentiated that, I'd have this 2 in front. So wouldn't that mean that I'd need a half in front? Because then if my function were a half x squared, if I differentiate that, I'd have, let me try it again, I'd have a half times 2 times x to the 1, right? Which is x, which is what I wanted. Now, actually, wouldn't it be true that I could have any constant here? Like, what if I had 5 here? That function's derivative would also be x, right? Because if I had a half x squared plus 5, if I differentiated that, I would still get just x, right? So actually, the constant here could be anything. So let me clean this up. So generally speaking, I would say plus c, a generic constant. Okay, so there's my antiderivative. Okay, what about the integral of 5? Well, wouldn't that have to be 5x? Because if my function is 5x, the derivative of that is just 5x to the 0, which is 5 times 1, right? Just 5. Okay, and again, that could be plus any constant, because if I had any constant here, say, when I differentiate, that constant just leaves me with a 0. Okay, what about this one? Let me integrate term by term. Okay, so this guy must have had an exponent 5/3, right? Okay, so if I had x to the 5/3, if I differentiate that, I would get this, right? So how do I get rid of this 5/3 in the front here? What if I put the reciprocal here? So let me see if now If I differentiate that, I get the correct result. Oh, looks like I do. Let's see if I can figure out this next term. Okay, so let's see. I would have needed a -4. And then let me see if I can figure out what that coefficient would need to be. Okay, so to get rid of this -4 in front, I guess I would need a, let's see, -1/4. Okay, so if I have -1/4, x to the -4, if I was to differentiate that, that would just give me 1x to the -5. Oh, let's see. I wanted a 2, though. I'm looking back up here. So if I wanted a 2, well, I guess I wouldn't want a 4 there, would I? I would want a 2. So we're kind of just trying things, and we're differentiating, making sure we get the right result. So let me try that then, and make sure that gives me the correct result. So now I bring down the -4. Okay, now looks like I have what I want. And then my 3, that'd just be a 3x. Okay, and then I guess plus any constant. Should I double check this somewhere and just make sure I get the correct derivative? So I'd have 3/5 times 5/3. Something like that. So then cancel, cancel. I'd have x to the 2/3, 2x to the -5 plus 3. Looks like I got that correct. Okay, let's see. Well, integral of e to the x is just e to the x. Let's see. Okay, what about this term? Well, let's see. I need an x to the -3. And then what would it be? Plus a 2/3? Okay, I'm just thinking of differentiating that, right? If I differentiate that, this comes down. Subtract 1. Okay, looks correct then. Plus constant. Let me start by rewriting this one before I even integrate. Okay, now let's integrate. So x to the 3/2, and then I guess I'd need a 2/3. Okay, let's see. 1 over x. So, I don't know, maybe I should leave x to the -1 as 1 over x. Because, remember, that would be ln of x, wouldn't it? Okay, let me see if I can figure this one out. Okay, I'm going to have e to the -4x. If I was to differentiate that, I'd bring the -4 down. So 2 over -4? See if that's right. -1/2? Then let's try differentiating this. Just down here, let's make sure it works. So that would be so cancel, cancel, cancel. I'd have x to the 1/2. I'd have 2 over x, and I'd have plus 2 e to the -4x. Looks correct. Let me rewrite this one as well, because you see how this t squared is dividing both terms in the numerator? So I'm not actually integrating here, I'm just breaking this up. So it's t cubed over t squared plus t to the 1/3 over t squared. So that's t. And let me see here. 1/3 minus 2. So t to the -5/3. Okay, now I'll integrate. And then I just have to see if that's right. So 1/2 times 2 times t minus 3/2 times minus 2/3. Okay, looks like I got that right. Okay, find f of x if f prime of x is 3x squared minus 6x and f of 2 is 4. Okay, well, if I know the derivative, then I should be able to find the function by integrating that derivative, right? With respect to x. So what would that be? Would that be x cubed minus 3x squared plus c? So let me just check. If that's f of x, then f prime of x Looks like that. Okay, so then what about where it tells us here f of 2 is 4? So that means if I plug 2 in here, that has to give me 4. So you see, that's going to allow me to solve for C. So there's my function. So I can check a couple things. If I take the derivative one more time, let's make sure that's right. That matches. If I plug in 2, oops, where am I plugging into? Try that part again. I'm plugging 2 into my function, my f of x function. So that should be 2 cubed. And so it looks correct. Okay, here's another one. Find f of x if... Okay, so again, f of x will be the antiderivative. Okay, so what is that? That's x plus e to the x plus ln of x plus c. Okay, now let me plug in the 1. And that has to be equal to 3 plus e. Okay, let me see here. What is ln of 1? That's 0. E to the 0 is 1. Excuse me. Okay, so then I have 1 plus e plus c. It's 3 plus e. I guess these cancel. Looks like c is 2. Okay, so let me double check this guy. Okay, got the right derivative. Let me check f of 1. Zero, so 3 plus e. Okay, looks good. velocity in feet per second of a train moving along a straight path is given by v of t equals 0.1 t plus 4. At t equals 0, it's at the station. In other words, it hasn't moved. Find the function that models the position of the train in t seconds. Okay, well, I know how to phrase this. Well, I know velocity is the derivative of position, right? Or in other words, position is the antiderivative of velocity. Okay, so if I want the position function, we usually use the s for position. That would be the integral of velocity with respect to t. So let's start with that. So what is half of 0.01, 0.05? It's my s of t function. Let me just double check. If I take the derivative, I get back my v of t. That looks good. Okay, what else do I know? I know at t equals 0, it's at the station. Okay, it hasn't moved. So what they're getting at there is, it must be true then that s of 0 is 0. In other words, the position at time 0 is 0, since it has not moved, right? Okay, so then let me plug that information in. S of 0, I'd have 0.1, or rather 0.05 times 0 plus 4 times 0 plus c, and that has to be equal to 0. So c would be 0. So I guess my position function would just be 0.05 t squared plus 4t plus 0.